we've reached the point where our two most important or our basic math concepts that we've learned so far, they're going to collide. So dimensional analysis is our process of converting units in science, and significant figures is the process that tells us how to round that answer that we just got using dimensional analysis. If you're unsure what significant digits are and you're unsure how to deal with them, well, I've got some other videos and they're going to pop up on the screen. They're also down in the description. It's going to be really hard to start at this point if you don't yet know what significant figures are. So go back and watch that. Also, it's up here on the screen. This is going to show up on my slides as we do our practice problems. So if you want to stick with me, I'll walk you through it. But again, you might need to go back. And if you haven't yet written this down so that you have it to be able to use through all of your science classes, write it down. You're going to need it. The other thing we need to remember are the operation rules. Now, the great thing is in dimensional analysis, which we're going to start to put significant figures and dimensional analysis together, it is all multiplication and division. So if you get that rule down about multiplication and division, you're going to do really well with significant figures and dimensional analysis. Now here's the thing, we have to discuss a few things. Metric conversions, and the last video we spent time on learning metric conversions and how to use this conversion chart. There are lots of ways to do them. I teach it with this chart because it gives a nice framework for learning dimensional analysis. But here's the thing, metric conversions are exact. So they have an infinite number of significant figures. What does that mean? That's best understood with an example. We need to convert 425 milligrams to kilograms using the correct number of significant figures. So we identify what is our known and what is our unknown, and we write them down. Those are our steps of dimensional analysis. Again, there are other videos on that if you need them as well. We've got 425 milligrams, mg, and my final goal over here is kilograms. Now, I set up conversions to cancel the units. The way I do that is I say, hey, I see milligrams in my problem. I don't want it in my answer. How do I get rid of it? Well, put milligrams down here because these are going to cancel. They're on opposite sides of the line. Then you ask yourself, what can I turn milligrams into? Can I turn it directly into kilograms? Well, not with the chart we're given. And that's partly by design because I want you to learn to troubleshoot and to problem solve your way through the math and chemistry. This is a good place to start troubleshooting. So I find milli, 1 milli, and this right now is milligram if we change the base unit to grams. Sorry for the bad handwriting. And that means these units change to grams. So we do have a relationship between milligrams and grams. 1 milligram is 0.001 grams. Notice it down here. Let's cancel our units. The milligrams go away because they're on opposite sides of the line. And I have grams on the top. But I don't want grams in my answer. I want it to be kilograms. So let's keep going. Number 2 over here says set up conversions to cancel units. So we need another conversion because we have grams here and we don't want it in our answer. And what has to go down here to cancel out those grams? Grams. It's on opposite sides of the line, so they will cancel. And I do know that there's a relationship between grams and kilograms. 1 kilogram is equal to 1,000 grams. Okay, so 1 kilogram is equal to 1,000 grams. These units cancel, we just talked about it, and kilograms are the only things I have left. 425 times 0.001, enter, divided by 1, I don't need to do that, times 1, I don't need to do that, divided by 1,000. If you don't understand this process, I went over it in the last video. Go check the last video out and I'll show you how I shortcut this. You can do it the maybe more understandable and long way by using parentheses around all of these. This gives me 4.25, need some room. E, don't ever write the E down. That E on the calculator means times 10 to the -4th kilograms. Again, the E on the calculator is referring to this. It's scientific notation. Now, here we go. This is great. This is lovely. This is wonderful. But the whole point of this was to figure out how many significant digits or how many significant figures I should round my answer to. And when I do that, in multiplication, I have to look at each part of the problem to decide how I round my answer. In this part of the problem, I have 1, 2, 3 significant digits. Then I need to look at this part. Well, let's think about this. This is an exact conversion. There are exactly 0.001. I'm going to make that exact. So that would be zeros. That line over the top means to infinity grams per 1 right here. 0.0000 to infinity milligrams. Here's the point. There are exactly, let's clean this up, exactly 0.001 grams in 1 milligram. So they have an infinite number of significant digits. I would just be counting zeros forever and counting zeros forever. So if these have a lot of significant digits, then I don't care about them because they won't help me. Not that I don't care about them. I very much care about them. I don't care about them for significant figures when I'm trying to figure out how to round my answer. So this is a metric conversion. Metric conversions have an infinite number of significant figures, which means I don't worry about it for figuring out how to round my answer. Same thing. This is a metric conversion, grams into kilograms, kilograms into grams. So I don't worry about the significant figures, which means this was the only measured thing in my problem. It had 3 significant digits, which means I get to have 3 significant digits in my answer, which I do. So our answer is correct. We just established then that metric conversions are exact, like the ones in this table. So they don't affect how we round our answer using significant figures. Interestingly, English conversions are also exact. Conversions between English and metrics are not exact in most cases. The best way to explain this is to do a practice problem together. This should look really familiar to the last practice problem we did, right? We're taking 425 milligrams and we're going to turn that into pounds using the correct number of significant figures. Nothing changes about our process for dimensional analysis. We write out in 425 milligrams, and then we need to do some conversions until we finally end up in pounds, which is LB or LBS. We look here, we set up conversions to cancel the units. So I don't want milligrams in my answer, which means I need to have milligrams down here, so they will cancel out. Then I say to myself, can I go from milligrams into pounds? Not that but look, I've given you a relationship between pounds and kilograms, which means if I could turn milligrams into kilograms, I could then convert it into pounds because there's a relationship here. But in order to get milligrams into kilograms, what do I have to do first? I first have to go back to the base unit of grams. Let's come over here and look. 1 milligram is equal to 0.001 grams. So 1 milligram is 0.001 grams. These are going to cancel. I'm left with grams, but I don't want my answer in grams. So what do? I set up another conversion factor. That's what number 2 is telling us right here. And I put grams on the bottom of that next one to cancel out the grams over here. Then I problem solve and say, what can I turn grams into? Well, I'd like to turn it into pounds, but I don't have a conversion for that. So what do? Well, I turn it into something that'll get me, let's turn it into kilograms. I look back at the chart over here and I find kilo. 1 kilogram is equal to 1,000 grams. So 1 kilogram is equal to 1,000 grams. Let's cancel the units right here. And this is really good. This is a really good example of the problem solving that needs to happen in chemistry class to convert units into something new. We're oftentimes not going to care about pounds and kilograms. We're going to have crazy things like moles or molar mass and mole ratios and Avogadros, but we have to learn those, which is why we're just using things we understand right now. Now, I'm going to keep setting up conversions because I haven't turned it into what I want, but if I look back down here, I can see that there is a relationship. 1 kilogram is equal to 2.2 pounds. This is going to cancel. This is going to cancel. And I'm going to need to remember this. This is not an exact conversion. We'll come back to that. Let's solve this right here, and then we'll round it with significant figures. Using my shortcut method, we have 425 times 0.001. I'm going to hit enter. I don't need to divide by 1. I don't need to times by 1 kilogram. I'll just take that whole answer divided by 1,000. I'll hit enter, and then I look at the next part of the problem. I take everything on my calculator times 2.2. I hit enter, and there's the answer on the screen. Now, the point was to correct number of significant figures. With multiplication, I look at each part of the problem to figure out, do I need to round my answer, or are we okay with this? Counting significant figures. In this, we have 1, 2, 3 significant figures. This one, do we count the significant figures? No, because this is a metric conversion. And metric conversions have an infinite number of significant figures, and we're never looking for the ones with a lot of significant figures. We're looking for the ones with very few. So we don't have to worry about that. This one, we talked about it on the last slide. It is a metric conversion. We don't worry about it for significant figures. This one, this goes between the English system and the metric system, and it's not exact. So we do need to understand this one for significant figures. Let's look at it. We're saying 1 kilogram, so that's an object. It's not a rounded off number. It's just a kilogram, is roughly equal to 2.2 pounds. It's not exactly 2.2 pounds. It's 2.20. We don't care about the other numbers. We just know that it's not exact. Because it's not exact, we need to look at the significant digits in that part of the problem. There are 2 significant digits. If we go back over here, we had 3 significant digits. Over here, we have 2 significant digits. And the rules tell me I need to round my answer to the fewest number of significant digits in the problem. So let's go back to this. I need to then round my answer. There's 1 significant digit, there's 2. But I always look at the next one, and if it's 5 or greater, I'm going to round up the next number. So let's write that out. That gives us 9.3. Oh, not 0.3, because look, there's a 5 there. That causes this to round up. 9.4 times 10 to the negative 4 pounds. And this is the correct answer with the correct number of significant digits. And this is a perfect problem to put all the pieces together. This is just dimensional analysis, but this is a little more complex. This is what we need to be able to do. We're given 2.998 times 10 to the 8th meters per second for the speed of light. We want to know, well, how many miles per hour is that? 2.998 times 10 to the 8th meters over seconds. I put that over seconds because I'm doing dimensional analysis. Miles per hour. When I get done over here at some point, I want miles, which is MI, per hour. Notice I have meters on the top. I want to turn it into miles. I have seconds on the bottom, and I want to turn that into hours. Can we do that? Absolutely. That's just dimensional analysis. I don't want meters, and I don't want seconds in my answer, which means I need a conversion. But the question is, well, which one of these do I convert first? Because pick one. It honestly doesn't matter. So let's say we're going to get rid of our meters here because I don't want meters in my answer. The only way to get rid of those meters is to have it on the opposite side of the line. But I need to troubleshoot my way and say, okay, I know I have to get rid of meters, right? But what do I turn that into to get into miles? I think sometimes it's easiest to start at the end and then work your way forward. So I can see over here, I have miles, and there's a relationship between miles and feet. So if I could get it into feet, I could turn it into miles. Well, there's a relationship between feet and inches over here, okay? Oh, and there's a relationship between inches, and centimeters. Well, look, that bridges the gap between the English system and the metric system. If I look here, I'm in the metric system, but my final answer, I'm sorry, I should be looking at this one, is in the English system. So I need a way to get between which means I can't go directly from meters into any of these things, but it does look like if I could get into centimeters, I can get into inches, get into feet, get into miles, and I'd have my answer. That's a lot of steps, but That's no problem. We can do that, right? Let's go from meters into centimeters. I look down here, I find 1 centimeter is equal to 0.01 meters. 1 centimeter is 0.01 meters. We're going to cancel our meters. We got to keep really good track of what we got going on. Now I have centimeters at the top, and I need to get rid of centimeters. So I'm going to put centimeters down here because I want to get centimeters into inches. Okay, then we put centimeters. Let's put inches up here. And we're saying that 1 centimeter is exactly 2.54 centimeters. Those cancel. Now I have inches on the top, but I want to be in miles. We keep looking through our conversions and we problem solve our way through it. Let's put inches down here because I need to get rid of those inches. Then I could go to feet, okay? And I say that 1 foot is 12 inches. How do I know that? Because, well, there's a relationship between them over here. Let's cancel our inches. Now I have feet. That's good because we said there is a relationship between feet and miles. So we set up another conversion factor, and we're going to put feet on the bottom, and we're going to turn that into miles. See, that's what we wanted it in, because 1 mile is 5,280 feet. I'm trying to write really small here to help us out. Look, we now have miles on the top, and that's what we want. So let's not mess with the miles anymore. On the bottom, we want hours, but if we look back at the beginning, the only thing we have on the bottom is seconds. So we need to turn that into hours. Well, that's okay. Look, if we put a conversion factor way over here with seconds on the top, will that cancel the seconds way over here? It absolutely will. And I know I can turn seconds into, boy, I could turn it into minutes because I know the relationship between seconds and minutes. 60 seconds is 1 minute. Now I have miles on the top and minutes on the bottom, but I want hours. So let's put minutes up here, okay? And I know I can turn minutes into hours. Look at us. This is good stuff. These cancel. Now look, the only units we have left anywhere, we have miles on the top through all of this work, and we have hours on the bottom. And that's what we want our answer in. So let's calculate it. 2.998. We use the EE button, which shows up as 1E, to represent times 10 to the 8th. So literally on the screen right now, that means 2.998 times 10 to the 8th. We take that whole thing times 1. I'm not going to do that. Take that whole thing divided by 0.01. I hit enter. I take that whole answer divided by 2.54. I hit enter. I take that whole answer divided by 12. Enter. That whole answer divided by 5280. Enter. That whole thing times 60. Enter. And one more time times 60. My calculator says 670,633,500.4. And what units? Well, I have miles over hours. This means miles per hour. 670,633,500.4 miles per hour is the speed of light. But we need to do this with the correct number of significant figures. This is just really a practice problem to see if we can deal with all that. So the way I do it is look at all parts of the problem. Look here. This has 1, 2, 3, 4 significant digits. This is a metric conversion, so we don't need to count the significant digits. This is not a metric conversion. 1 inch is English, centimeters is metric. But look, I chose that one as a conversion for you because it's exact. Because that now is not going to mess up our like we're going to end up with good significant figures in our answer. So we don't need to worry about it because it's an exact conversion. Same thing here. This is the English system. Conversions within the English system are exact. This is the English system. Conversions within the English system are exact. This is the seconds, really is system international. Time is, you can think of it as the metric system, which means there are exactly 60 seconds in 1 minute. If there are exactly 60 seconds in 1 minute, this is an exact conversion. We don't count the significant. Same thing here. We don't count. So the only thing Where we had to count significant digits was our number at the beginning, and there were 4 significant digits. So I get to have 4 significant digits in my answer. There's 1, there's 2, there's 3, and there's 4. I always look at the next one to see if it's a 5 or greater to round this up. It is not. So let's round it to these 4 significant figures. 6, 7, 0, 6, 0, 0, 0, 0, 0. I'm going to put commas in here just for placeholders so we can see this. Miles per hour. This is the correct answer for the speed of light when we start with 2.998 times 10 to the 8 meters per second with the correct number of significant figures. This is a huge leap. Like, if you're able to follow along with me and this is making some sort of sense to you, then you're doing really, really well in introductory chemistry. And if it's not, well, there's more practice problems about to come up, and there's a lot more learning coming, and you're going to get there. You're going to be really, really good at this if you stick with me. I have a lot more help popping up on the screen. Come over to bealsscience.com and watch a bunch of great chemistry fun and excitement. And then go to bealsscienceschool.com and you can learn more about chemistry, and I hope that you keep on learning.